In this video, we will be discussing about electric potential difference. From our discussion about current, we know that current is the flow of charges. But what causes this flow? Well, this situation is analogous to the flow of water. So let's use water flow as an example. We know that water in a horizontal tube does not flow. However, if the tube is tilted, water flows out. What could be the cause? Well, water can flow only if there is a difference in pressure between the initial and final points. This required pressure difference is provided by the gravitational potential energy. Usually, water flows from a region of higher pressure or higher potential energy to a region of lower pressure or lower potential energy. This can be attributed to the general tendency of systems to remain in the lowest possible energy state. This state is considered as the most stable one. Hence, all systems will tend to move from higher energy state to a lower energy state. Now consider the diagram of the building. It has 2 points marked on it. One, a blue point which is a topmost point, and a red point which is a bottommost point. We know that the potential energy or gravitational potential energy is equal to mgh, where m is the mass of the object, g is the acceleration due to gravity, and h is the height. This potential energy increases as height increases. Hence, the point marked blue has maximum potential energy than the point marked red, as the blue point is higher than the red point. This is why we have water tanks placed at the top of buildings. Water can flow out from the tanks to the pipes without any external source. The water in the tank has higher potential energy, hence they utilize this potential energy and convert it to kinetic energy so that they can flow down through the pipes to a region of lower potential energy. However, the reverse process, that is pumping water up to the tank, requires external agents like an electric motor. It is because the water in the well has lower potential energy, and to take it to the tank we have to do work on them, which will increase the potential energy. But is gravitation responsible for charge flow? We know that gravitation or gravitational potential energy is responsible for the flow of water. But is that responsible for charge flow? Let's find out. Well, the gravitational force between two objects is calculated using the relation F is equal to g m1 m2 by r square, where m1 and m2 are the masses of the gravitating objects, r is the distance or the separation between the two objects, and g is the universal gravitation constant. The mass of the charge carriers are of the order of 10 raised to minus 31 kg or 10 raised to minus 27 kg, and hence the force experienced between two such objects is very weak. But we know that the current is established almost instantaneously. Like as we turn on the switch, the current flows through the circuit. Suppose we are turning on a bulb. If we switch on the circuit, the bulb glows instantaneously. If gravitation was the force responsible for the charge flow, since the force is very weak, the acceleration it produces is also very weak. Hence, charges will take a lot of time to travel from one point to another. Hence, an instantaneous connection cannot be established using gravitational force. Hence, we can conclude that gravitational force cannot be responsible for current. Well, charges flow due to the difference in electric pressure also can be called as electric potential. But what produces electric pressure in our common circuits? Let's find out. Electric potential. The difference in electric potential in a circuit is usually produced by an external agent like a cell or a battery. Well, the battery has energy stored in the form of chemical energy, and this can be used to drive electrons across the circuit, resulting in the flow of charges and thus the current. Well, now we know why batteries are exhausted after a certain period. They run out of their stored chemical energy. It is all used up and the battery is drained, so they cannot produce more current. So we have to either recharge them or replace them. Since work is done or energy is being utilized by the battery during the flow of charges, we can define the potential difference in terms of work done. It is defined as the electric potential difference between 2 points in an electric circuit carrying some current is defined as the work done to move a unit charge from one point to the other. So in a circuit, the electric potential difference between 2 points is actually the work done in moving 1 coulomb, that is a unit charge, from between the 2 points. Now let's find out an expression for electric potential difference. Suppose the work done in moving q coulomb of charge between 2 points in a circuit is W joules. Then q coulomb requires W joules, or q by q, that is equal to 1 coulomb, requires W by q joules. Here we have divided the above equation by q on both sides. Hence, the work done to move unit charge, that is 1 coulomb, is equal to W by q joules. This is precisely the definition of potential difference. Hence, we can conclude that the potential difference represented using capital V is equal to W by q. The SI unit of potential difference is volt, which is named after the Italian physicist Alessandro Volta, who lived from 1745 to 1827. Well, we have defined that potential difference V is equal to W by Q, and the unit for SI unit for work done is joule, and that of charge is coulomb. Hence, the unit of potential difference can be expressed as joule per coulomb, which is equal to volt. Well, the SI unit for potential difference and the letter we use for representing potential difference are the same, capital V, so please be aware of that to avoid any kind of confusions. If the work done W is equal to 1 joule and the charge Q is equal to 1 coulomb, then we get V is equal to 1 volt. Since V is equal to W by Q, 1 by 1 is 1. This can be used to define 1 volt, which is 1 volt is the potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to the other. So if work of 1 joule is done to move a charge of 1 coulomb from one point to the other, we can say that the potential difference between those 2 points is 1 volt. How do we measure potential difference? To measure that, we use a device called voltmeter. It is very similar to that of an ammeter, but there are some differences as well. It has 2 leads, a positive and a negative lead, which is to be connected to the points across whose potential difference are to be measured. It has a circular or a semicircular scale and a pointer, which will point to the correct value of the potential difference. Well, a voltmeter, unlike an ammeter, is connected in parallel to a circuit. We'll come to what is parallel and series connection and all later. Well, just remember that the voltmeter is connected in parallel to a circuit, while the ammeter is connected in series to a circuit.